Good morning, everybody. Good to see you guys. I hope you had a great day yesterday at the conference. Big thank you to the volunteers and to the organizers for putting this on. DevConf is such a special conference. You know, many of us have been to the one in Europe, maybe, or India, and the one here in Boston is such a great conversation because it's kind of very intimate, and it's also like, on the BU campus, so it's a lot of students, a lot of people learning. And today you're going to be learning a lot about inferencing. Inferencing is that process when you're talking to a model like ChatGPT or running one locally and you're having a conversation back and forth, or maybe you're using your documents with RAG, or you're having the AI do something with tool calling and agentic capabilities. And Roberto and I, we do all day essentially, and sometimes all weekend, is spend time learning about the newest technologies and actually using them, helping developers learn within our job and as our hobby too, right?
Yeah, as well.
And so what we're gonna teach you and show you with a lot of fun live demos today is, one, how to use vLLM, two, why use vLLM compared to other options that you might know about, such as Llama C++ and other inferencing runtimes. And then three, we're gonna see it on Kubernetes, right? That's where we're deploying our applications and containers.
Correct.
And we're going to, in this method, deploy the model alongside as kind of like a microservices-based approach where you have different models, right, for specialized use cases. And we're actually going to see that. We've got some fun live demos here that you're going to see today. One of them is testing out concurrency. One of them is vibe coding.
Vibe coding, yeah.
Yep. One of them is running large models.
Correct.
And so let's hop into it. So just off of that, how many of us have worked with Rama Llama or Olama or any of those tools that can let you run like a local model?
Sweet.
Okay, awesome, nice. And how many of us here are maybe developers? Cool. Anyone's like a sysadmin, ops type of person? Thank you for your service. DevOps, Linux admins, data scientists maybe? Okay, nice.
Sweet.
Very cool. All right, so yeah, good mix of people in this room. We're developers on our side, but we've learned a lot in the operations side because on top of this is going to be, our infrastructure layer is Kubernetes, right? Don't get scared. The meme here is kind of small. It's like kubelet logs when something doesn't work. And, there's that typical, hey, it might be complicated on Kubernetes type of approach, or that it might be expensive, right? Because all we hear about is, hey, LLMs are super resource intensive, need accelerators. The fun part is you actually don't even need GPUs for some of these models. You can run these on CPU, which is really incredible, because of a lot of recent advancements in small language models. And by the end of this, you'll be an expert on vLLM, on Kubernetes. And if you'd like to join us with the slides here, feel free to. But we'll start off with, hey, running your own AI and LLMs. We'll show how to work with vLLM on top of Kubernetes and scale things up. And we got a couple fun demos.
Yeah, let's go.
Let's kick it off. Cool. So everyone's running their own AI models, but the thing is, it wasn't always like that. If you rewind, about 2-3 years, open source LLMs didn't have the funding and didn't have the resources to catch up with proprietary ChatGPTs or the other frontier models that we commonly think about now, right? And so it's mainly a data thing, but now there's a lot of open source models and a huge ecosystem for running those that we're going to talk about today. And you think of models from Llama, from Meta like Llama, but also Google, Microsoft, like all of these huge companies that have proprietary models also have their equivalent of an open source model that can pretty much match those benchmarks. And it doesn't matter, what company it is, they typically have their own model. IBM has theirs, Meta, DeepSeek, these are commonly used models that we see on-prem devices like a system like this, or in the cloud, right? You have offerings from every hyperscaler to run their own AI models for you, right? But then you're sending them your data, so that can get quite kind of tricky. The advantage with open source models that you have is, that's nice, thank you, is predominantly around two things. So it's cost, being able to scale whenever you need this model, right? Instead of just paying for the largest model of 2 trillion parameters, you can have something like 70B that can do what you need, but also the maintenance. People don't think about, hey, let's say there's a new release, right? ChatGPT 5 comes out, and they don't think about, hey, I have to now rewrite my application or integrations with this new model, and maybe some things are going to break, and maybe I have to rewrite my code just because I don't have that flexibility of maintenance of control of going from V1 to V2, right?
But security is important as well, right?
As a developer, we sometimes forget about that, right?
But we should focus on that.
Yeah. And I guess, thinking about the whole stack for it, right? It can be kind of overwhelming. So this was like about a year ago for the entire, machine learning and AI data landscape, right? So you think about tools from inference, what we're talking about today, to monitoring, to evaluations, to much, much more. And I guess sometimes we can kind of, feel like this, right? Where we're trying to understand the newest technology, and sometimes something that comes out right now is depreciated in 6 months. So it's a really rapidly evolving landscape. But the vLLM project that we're going to be using today in these demos has been kind of deemed as like the Linux of generative AI inference.
All right.
Right? So it's becoming the standard because it adapts the OpenAI API protocol and a lot of other capabilities that you're going to see here in a little bit. But you don't want to be like this, where you're...
I'm the poor developer that I don't understand anything, so I just want to use my model. So how you can help me?
Well, that's a great question. I'm glad you asked, because there's some open source tools. We're at an open source conference that can help you run these AI models. Some that I see we've already experimented with, so we'll test these out. But it's beyond just the model that you're going to see today, because I have a lot of fun just testing out, like pulling from Hugging Face or seeing what the newest model is. But when we're actually trying to build applications around this, it's the model drift, right? It's the configuration around the model. There was a big report, I think 2 days ago, that Claude came out with and said, hey, the reason you've been seeing differences in the model output, because everyone's using this for vibe coding and saying that, hey, it's not working as it used to. But that was actually an infrastructure thing and not a model issue. And so people were seeing depreciated performance because of the infrastructure around the model that we don't commonly think about, right?
So the model is not enough, right?
The model is not enough,
All right.
exactly. And this can really impact the AI applications that we build, right? And building these applications, right, it's a lot of different tools, libraries, and from an infrastructure capability, orchestration, right? So when we're running, say, for example, Llama, which is a way to run LLMs through containers, we would use maybe Docker or Podman. Or as today, we're going to see Kubernetes. Underneath it, right, is the accelerators. Maybe it's NVIDIA or another GPU, right, that we're working with. And on top, what we're going to see today is the libraries. Think of LangChain in order to make calls for my application at the client side, or all of the other ways to manage our data.
All right, so it's not just my machine learning libraries any longer. I need to take care of the other things, right?
Precisely.
All right.
We'll show that here in the live demo. A lot of us raised our hand for working with maybe Ollama before, and this is built by a former Docker PM.
Right.
So it's a very similar, Docker pool for a model to do a Ollama pool and run that. And it's very similar with also a model file. So you could pull something from Hugging Face and run that in a model file and kind of do customization around the prompts.
But this is in my laptop. What if I want to go to production? I need to put my Ollama as well in production in Kubernetes, or?
I'm glad you asked. That's a great point. So we'll talk about where you go after this, right? Because this is a really handy tool, as you mentioned, but we can't throw this in our cluster because it's not made to scale up, right? And we'll talk about why here in a second. And we'll actually show why. We have a really fun demo. But the second tool that Dan Walsh is here, so I got to talk about this, is Llama. So this is under the containers organization on GitHub, and it uses your container runtime, be it Docker or Podman, in order to pull down a container image with Llama C++, mount the file, which is a quantized model, so Llama 3.3, for example, and then run that with acceleration through the container, which is a pretty cool setup.
That's pretty cool, yeah.
We talked about, hey, I can't throw this in a cluster, right? And we'll see why here in a second. The tool that we're going to be focusing on today is vLLM. So it's a research-based project. There was a meetup the day before the conference, which was really cool to see all the, community around it. It's about 60,000 stars on GitHub, and it's a perfect fit for Kubernetes because one, it can take advantage of that kind of scheduling, right? So if I need capabilities at 5 p.m. on a Thursday with these AI models, I can scale that up with Kubernetes. But then it also very effectively uses the KV cache. So let's say we have a L4 GPU, right? So this has about 24 gigabytes of RAM. If we're not using that memory efficiently, we're essentially either wasting money or what's the other option, I guess?
Well, not be very, very performant because not using the GPU as much as we could, right? We need to be able to scale in production as well and adding more GPUs. So how we want to, for example, deploy the larger models because the very large ones cannot fit in your laptop, right?
Exactly.
We will see in it also in a couple of minutes.
Because if that GPU only has 24 gigabytes of memory, how do we load something that's 400 billion parameters and takes 200 gigabytes of space?
Correct.
When we talk about scaling things up, I just want to show you really quickly this funny demo that we made. So let's start off a model. So I hear I'm running, and I know it's really small, but I'm running Llama 3.2. That's using Ollama, but you could think of maybe Ramalama or any other inferencing utility on my Mac. So say hey, and then good to go. And we're connecting to it from a simple TypeScript application. You'll see how this works here in a second. But this is my interpretation of the Boston Harbor. You know, I'm from New York. We don't really have a harbor. Well, if we do, but there's nothing living there. And so what we can do is kind of spawn these guys in. But let me start this over again just because I did this on a hotspot, and so maybe it's being a little weird. But yeah, so we'll run the model, and then I'm just going to, let's see if we can add these guys. Okay, 1 second. Port 154. So I have a couple little creatures that we're going to add in here, and then we're going to make a call to the model and see if it can pull some chats out. But give me like 2 seconds. I wonder if it's the vibe coding that we did yesterday.
Maybe
we come back to this in a little bit so we can show some other demos. That's all right. So this was just a local example that we'll come back to, but I'll pass it to you, Roberto.
All right.
VLLM section.
So let's talk around what's unique in vLLM. The thing is that we have, when we want to do AI inferencing, it's very challenging because we need to be able of having, for example, our infrastructure, we have our GPUs, and they need to be very efficient because are very expensive. So we need to be able of using it in the best way possible, and also try to not put like bottlenecks. We need to able to put some latency solutions, and also we have the model optimization that requires also the ML experts. So this is the different things around the AI inference that we are trying to address with vLLM. So vLLM is the de facto standard for the OS inferencing. Right now we have this start as well, but it's like the Kubernetes for the different microservices and container orchestration project. So if you wanted to put it in production, Cedric said that we have Ollama in your laptop, but if you wanted to grow towards more distributed inferencing, we need something that scale. And this was also the purpose of vLLM at the first papers, and the community grow very, very fast because they wanted to put this in production in order to do the distributed inference across the different GPUs. So this is the community around that. The good thing is that vLLM is capable to run on different hardware, and that's also enabling a lot of our customers, users, and the community to not only run it on NVIDIA, they can run it also in different AI accelerators, leveraging all of these open source community as well. And also we have the possibility of running in almost every model out there, like the most famous from Llama, Mistral, Qwen, DeepSeek, you name it. In fact, GPT-OS, that was the open source OpenAI model, was also vLLM from day zero. And that's one thing that also is very, very important. And as I said, it's cross-platform, so you can run all of these models in any single GPU out there, or AMD, in TPUs as well, in different environments, because you can run it on-premise, but also in the cloud. And that's important because you wanted to have this hybrid solution in order to, no matter what, you wanted to run it also on-premise or go to the cloud and have the exact same look and feel and same experience. So how you can use it? It's super simple. It's just one command at the door. You can run it like with a Python interface because you have also all of these Python libraries, but also you can run it with just one command, vLLM's. And that's more or less the exact same thing when we wanted to go to Kubernetes with KSEF with more native solutions. And we have a couple of features of vLLM that we wanted to emphasize. The first is how to make your models faster. That's the most important part where we want to deploy our models, and how we can deploy bigger models efficiently, because we want to have these capabilities of having bigger models, but also being optimized in order to reduce the amount of hardware that we are using from the AI accelerator perspective. First, to have these inference optimizations, we have to first to be able to quantize the models. What's quantization? It's grabbing a huge model and compress it in order to do it, like, for example, a picture or just a zip, in order to put and grab all of the weights that it's where the knowledge around the model stores, and afterwards convert it and compress it in order to reduce the memory footprint, but not making the model a little bit dumber. It's maintaining the same accuracy and the same knowledge around the model perspective. So with that, the benefit is that we can run the LLMs practically in not only very large servers. We have also the possibility of deploying it in your local machine, in IoT, and the result is we have faster and lighter models, and can run also on GPU, but also on CPU. So you can unlock a lot of different situations that you don't need to have a GPU in order to run these models. Obviously, we know that there are certain limitations, but very good to go. And we have a bunch of different quantized models. In fact, we have this repository that if you scan it, will land in the Red Hat Hugging Face. Hugging Face, you are familiar with Hugging Face, right? Right. A lot of yeses. That's lovely. So in this, you will land in our Hugging Face repository in Red Hat AI, and you'll see a lot of quantized models ready to go, because we have an engineering team that tests it, and also alongside with the community, we have these that the hosts have ready to deploy, and you have also the possibility to run it in different hardware, not only in NVIDIA or in AMD. You can run it everywhere. Another thing that it's interesting and it's out of the box, it's automatic prefetching. Imagine that Cedric is trying to request one thing, and myself as well. And the only difference is I'm using hello, and Cedric is using howdy, for example. It's looking similar, and this will, the first time, take a little bit more time, but the second, the KV cache, where everything is stored, will be faster, because instead of just calculating again and again and again, this will be very, very fast in order to be able to respond and make the conversation faster. We will see in it. And also with the merge-to-turn conversation, like the chatbots, you will have the exact same thing. This is shared and then will be much more faster. So you'll see this is like an animation around without optimizations and with vLLM. We are adding, for example, prefix catching and also the KV cache, among other things. And as you can see, just we have a much faster response of the prompt, because we are using different things. We are using prefix catching, again, because we know and we store the KV cache. And also we are using other things among, for example, the quantization of the models. This is faster, but also it's more optimized. So you can run the models in less GPU power, for example, as Cedric mentioned afterwards. Another thing is how we can run these models, these very huge models, in less hardware. But if, for example, I have only one GPU, how can I do it? The thing is that we started with a single device, a laptop, but we wanted to also be able of piling the different GPUs out there. Because if I have 4 GPUs, I wanted to be able to serve these models in the different GPUs that they have, right? So how we, or at least why do we need distributed inference? Because usually the larger models like DeepSeek cannot run in one GPU. It's impossible. So we need to be able of adding all of the GPUs and do the distributed inference across different GPUs, because we have models larger than that cannot run in just one GPU. And also we have to have some bandwidth in order to aggregate the different GPUs in order to be faster when we are distributing and also serving the type of the models. And we have different techniques that we can show. Usually we have in the models 2 different variations: model MEOE, model of experts, and very large models. Usually the things that we have is like DeepSeek, it's a mix of experts. So instead of just one model and one expert, we have a variety of experts inside of the exact same model. So knows how to calculate math, knows history, it's an expert in different things and has been trained with a lot of things. And we are trying to split all of this and distribute across different GPUs. Every single node in here is a GPU, so we can distribute all of the models across different GPUs, making, for example, that instead of using one GPU, we are using different GPUs across our infrastructure, and we can be more performant and more efficient in our calculations. And now we can see one thing around our model, because we have more models as a service, and that is one technique because, for example, we want to run our models and share it among the different Red Hatters internally, and we wanted to deploy this. So the thing that we did is to grab this model, and also as you can see, we used different GPUs in order to serve it. So let me just go into the API Explorer, and you will see how easy it is, because we have the inference service, and also we have the Llama Scout in here. And if we inspect this model, we will see, just give me a sec. Yeah, a little bit bigger, sorry. With the plus, right. Yeah. As you can see, we are using just one flag, and with this flag, we are piling up and we are splitting the model across the 4 GPUs that we have in the same node. So this will be able to accomplish this one. We are grabbing one of the largest MetaLlama models, and we are distributing across 4 different GPUs in the same node. But we can also put our models across the different nodes with multi-node, multi-GPU. And that will be also a way of, for example, adding a lot of things around that. And if we go and see the VS Code, for example, we have our root code. So in our root code, I'm using Lightmass, that in this case, I'm using the different models that we have. We have DeepSeek, Llama for Scout, Mistral Small, and at the end of the day, are the different models that we have in here. So we have DeepSeek, also Llama for Scout. So we can, for example, just give me a sec, save it again, and hopefully we will have a response if the Wi-Fi allows, because, all right. So I want to run, or I want to modify the backend.
And I guess just as a little bit of context, so this is one of the extensions that's open source, like Clyburn, that you can embed in your IDE.
Yeah.
And then it pulls the context of all your directory and your project structure.
Correct.
And can do inline edits, right? So it's a VS Code, but you're not sending your proprietary code base.
So we are
Microsoft, right?
we are using these models in order to do vibe coding. So I'm connecting to the endpoint, and to the endpoint, I'm using just a base URL, and I'm using an IP key. I'm selecting the model, Llama for Scout, and I'm doing this vibe coding as well, sending a lot of different things. So if I just I want to extend the API, I will see with another example. It's a little bit tricky to
right here, one hand.
Yeah, another API with another example. Just give me a sec. As you can see, it's going. Oh, sorry. Going against GPT. Just give me a sec. It's raw code. This got changes. To extend the API. All right. So this is going against my endpoint. And as you can see, I'm having, for example, and I can select the different things. If I go to the pods, I will see all of the inference around that. But at the end of the day, it's using a very large model in order to consume all of this. And you can see the amount of different tokens that I'm doing it. And this is vibe coding right now using just my private AI without leaking or without going to OpenAI in order to use it. So everything that you can see, it's all of the vibe coding that I'm using because this is like only using my endpoint.
So this is really cool. And would you be able to go back to that page? Because we actually have another extra bonus demo on the Mistral model. That's a blackjack game. We can maybe run that real quick.
Nice.
Sorry, the first demo didn't work, so we had backup demo, and it's working. Trust, it works on my machine.
It was in my cluster.
In my cluster, yeah. So over here is a simple example of well, I would say kind of using an API in the middle, which is called Llama Stack, that connects to vLLM. So instead of just doing all the calls using a specific library like LangChain or CrewAI or something like that, we're actually just able to do it to a singular API, which includes capabilities like, well, let's actually go there. I think it's what, /docs to get the Swagger?
Yeah.
Yeah. Capabilities like agents and tool groups and, of course, inference. So what we're working with vLLM for, but data sets and telemetry and stuff like that. So if we come over to here, this is our little blackjack game. And if you'd like to join, feel free to scan this QR code. And this is quite a fun game that you can play on your mobile device real quick. And it utilizes one of the models that Roberto is showing, but it also uses that prefix caching. So since we're going to be using the same prompt template every time, hey, you're a blackjack coach, and you're going to have a blackjack coach in the game, it's able to speed up those requests and use vLLM's features in Kubernetes.
Out of the box, because we will use also another model that it's served across different GPUs, and we are using Mistral in this case, a very large ones. Yep. So let's see it.
All right. So typical blackjack. We're at a 15 hand. Should I hit or should I stand? Hit.
All right. Let's go.
Sweet. So let's try it. Oh, it was ace. Okay. Let's hit again. And let's stand that. Right. So this is typically what we would do, and sometimes we win. Hopefully. Most of the time. But if I'm new to blackjack, right, I could kind of create some type of AI feature that here in the back end is going to make a request with the cards.
Ooh.
There's a bug. Awesome. There's a bug with it, and it accidentally shows you the turned card. And we learned that the other day. Didn't get to fix that, but maybe with the vibe coding.
We can do it. Yeah.
But then in the background, if we can head over to your dashboard, we can see that all these requests are coming in, and they all say, hey, you are a blackjack coach. You need to help with the current.
Yeah.
Yeah.
Here we go. All of this, and it's requesting right now. And the people are you are a blackjack expert, respond with only JSON objects. So the people is we lost people because it's just playing.
Yeah, but you've got the same instructions and it's, using some of those features, right? as well as the OpenAI API to the
API as well.
completions that I can swap out with Ollama, or I can swap out with ChatGPT or any proprietary model.
That's brilliant.
Yeah, so hopefully you guys get lucky, and hopefully the AI, let's ask it again.
And it's faster, right?
It is faster, and it's pretty cool because in this models as a service that we're using, we can see the statistics of this blackjack model, and so we've used it 15 times today. But if I go zoom out, we did an event and it was used, 1.2 thousand times, right? Scales up
Right.
very efficiently, and yeah, and I hope you enjoy that part of the demo. So.
And for last but not least, we want to also introduce another project that is called LLMD, because sometimes we wanted to use a distributed inferencing, and for that reason, Red Hat, among other big players like Google, like IBM, created LLMD. That it's a way of doing natively the distributed inference on Kubernetes. It's a very young project, but got a lot of attraction right now. The community is growing very, very fast. And we are having a lot of different features that we can expand in another talk, because this could have a totally another talk separately. But hopefully you'll enjoy the talk. And I don't know if you have any questions so far, but hope you enjoy it.
Yeah, thank you guys very much.
Sweet. Any questions, gentlemen? Mm-hmm. Yeah. That's a very good question. That's a very good question. I should repeat it. So essentially, the gentleman's question is why we are using custom runtimes in OpenShift AI instead of out-of-the-box ones. I can respond to that because we use that because sometimes we are testing flagship and frontier models that we are using unstable version of OpenShift AI that comes with sets and vLLM container image. But the good thing around OpenShift AI is that you can select different custom server runtimes, and we are using some of them that, for example, are ahead of this stable version. So for deploying DeepSeek or deploying the GPT OSS, we needed to go to one specific vLLM version that was not included out of the box. So we cooked. But at the end of the day, it's grabbing just one image, and that's all. One thing that we can do is just go to the YAML itself and to the different inference service. And this inference service, as you can see, we have a bunch of different versions. But for certain cases, like Llama, for Scout, we wanted to have control as well. And Cedric mentioned it. We wanted to use, like, first the quantized models. So let me just do it a little bit bigger. These quantized models, but also use different things around and having control around the different containers and the different version that we are using. And there is another part that is called serving runtime. So this serving runtime, as you mentioned it, we are using different versions, as you can see. And one of them was GPT OSS, because this was very, very new. And we needed to use other type of container images specifically for that until we have it in the version that we want out of the box. But very good question. Hope that I answered. All right, brilliant. Any questions so far, gentlemen?
You mentioned that you can do AI inference on GPU.
Yep.
Was that running on GPU or is that running on?
This is running on GPU.
Sorry, you mentioned on CPU.
CPU, right. We have different versions and we have different models in here. And we have one that is called Tiny Llama, and this is running on CPU. This fella is running only on CPU and not on GPU. Obviously, the performance will be less. So this is not using any thing around GPU. And in fact, it's in one node that it's a regular CPU node, one Intel one. But the thing is that special is using a special serving runtime, and this serving runtime does not require one specific GPU. So I'm running fully on CPU. The other ones, though, are running on GPUs because are huge, essentially are massive. So you cannot run Llama for Scout on CPU. You will burn literally the computer or in the server.
Are there ARM64 images for all of the software running?
There are, and in fact, we are supporting some of them. We will add more support around the ARM ones. Right now, there are a couple of efforts in order to put the different ARMS ones. Usually, we have 86, and we will have also ARM ones. And the community is going towards that because of the efficiency and also having other options.
Can I work around here? Can I connect with you?
100%. 100%. Awesome. I appreciate that. All right. So we are run out. Thank you very much.